Hello, hi. Here in this particular video, we are going to discuss about Docker architecture. I will show first Docker definition from official Docker site. So this is the official Docker definition. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure, so you can deliver software very quickly with Docker. You can manage your infrastructure in the same way you manage your application, but by taking advantage of Docker's methodologies for shipping, testing, and deploying code. You can significantly reduce the delay between writing code and running it into a production. I think by this time some people got certain idea about the Docker. No worries if you not got any idea on this. I will go through the Docker architecture from the official page also, and by that you will get a clear understanding on this. So first of all, let's see, like, not in a technically, like non-technically. Okay, so if you understand non-technically, then it will be very much clear to you to go with the technical. Okay, now what is Docker? We just change the definition one more time in the technical way. Okay, so basically Docker, think like Docker is like a shipping container. Okay, like how the physical container is there, like that. Think it is just like shipping containers, how it revolutionized the global trade. Likewise, Docker container, it going to revolutionize the software development. Okay, so in physical container, what we are doing here in this physical container, we are there is a standardized box that holds goods safely during the transport. That is the purpose of physical container. Apply the same thing in Docker container. Here, instead of goods, we are keeping that applications. So a standardized packaging that holds your application and everything in it. That is basically a container. Okay. Docker is a platform that packages your application with all its dependencies. It's a lightweight and portable container. I think you got certain idea like how the Docker holds the container. Now let's go into some more deeper. Okay, by after saying this definition, I will go with the diagram also. By that you will clearly understand. Basically, there are three core components in Docker where it together works and communicates. Then only the Docker container will be built. Okay, the first part was Docker client, and second part was Docker daemon, and third one was Docker registry. Here the Docker client is like a command center, where you are going to type a command like docker run. Okay, then it is going to give a command to a Docker engine. Okay, so in Docker engine there is a Docker daemon. So whatever the command you are typing here, that will be goes to the Docker daemon. Okay, it is basically the powerful engine running in the background, and it does all the heavy work building, running, and managing the container. Okay, and the Docker registry, it is just like App Store or else GitHub registry repository, we can say. Okay, how uh, App Store, sorry, like an App Store where you download the pre-built images. That means Docker Hub. Docker Hub is the registry example. Okay, so you can store your own images also. You can use the pre-built images. Okay, likewise. Now let's go into a diagram and see the components. Okay, here if you see here, whatever the components we just seen, that is this. First one is Docker client, and the Docker host, and then registry, which is Docker hub. Here, let's understand first these dots. Later we'll go with technical. Okay, this particular dot will indicates to build. This dot indicates to pull, and this dot with line indicates to uh, Docker run. Okay, now we are going to see what exactly the build does. Okay, if you see here, client is just like a CLI where we are writing a commands. Okay, and Docker host, it has a Docker daemon where it will runs the actual commands whatever we are parsing from the Docker client, and actual work will be done by Docker daemon. Okay, now let's say if you run a Docker build basically means with the help of your image, with the help of your Docker file, it was building a image. If you see here, the line will be like this. Let me take another pen. Yeah, sorry, let me take green only. Okay, you are just giving a command docker pull and docker build to a Docker daemon, and Docker daemon will just create a images and keeps in Docker daemon only. Okay, it will just creates image. Then you can push into a registry if push command is there. Okay, and that is basically a Docker daemon. And if you see Docker pull, you are just giving a how Docker build command you are giving. Here also Docker pull command you are giving to your Docker daemon. And what daemon does, it will check if any image is available or not. If the image is available, okay, like whatever, I mean, after this Docker build, there will be a certain details we need to give, like image name and the tag also. Okay, so then only it will identify and fetches the correct image. Let's say if you use a image which is having in this, okay, that means just now you build a image stating that Docker build and some XYZ name. Okay, so if you use Docker pull, sorry, yeah, Docker pull, basically it will pulls the image from here. Okay, if it was already exist, then it says Docker image is already exist. Okay, let's say if you pull this particular image, X image, Docker pull X, then it will Docker daemon first what it does, it checks in the Docker host. Okay, so if in the Docker host it is not present, then the daemon goes to a outside and it will fetches to the Docker host. That is how basically it works. If you see here in this particular example only, in the first command we are building a Docker image. Okay, so we just build a Ubuntu image. Okay, and in the second command we are pulling the Redis. Okay, we are pulling the Redis image from Docker registry. Let's say if we wanted to run the command, run the image, that means we need to create a container. In that case, we just give a command to the Docker daemon, and what it does, it will first check the image is available or not in the locally. If it is available, then it will form a container. If it is not available, then it will goes and fetch the images, and from here it will creates a Docker container. This is the like how you need to understand things. That is only here the lines also, which is represented something different, dotted line and dot with line. Okay, and here if you see in the registry we have Ubuntu, we have CentOS, we have Redis, we have Nginx. So Docker registry is like Docker Hub. This is the whole logo of Docker Hub, where Docker Hub, it has uh, Docker daemon, basically a Docker engine. Okay, so we can have the images there, we can push the images, we can pull the images. There is a CLI also within the Docker registry, the Docker hub. Okay, so yeah, that is the thing you need to understand. And one more architecture I will bring. This is the like official Docker architecture. Okay, like from the official documentation. If you see, compare that and this, it will be the same. Okay, first we are did Docker build from Docker file. We are building our own image. That means either Docker Daemon does our job. Okay, so image will be built now. Now the next command was Docker pull. Let's say if the image is not available, then what we are doing, we are going to a registry and we are getting our image. Okay, and then we are running, we are checking if the image is available. If the image is available, we are running the container. If the image is not available, it will go and fetch the image, and then this image will be run. That means it will form your container. That is how it basically works. Okay, and there is a network, Docker network, where internally, let's say Docker, one Docker container or Docker image need to talk with another. We can do that. Okay, and also one more thing, this Docker like client server architecture, right? This is a client. How it, I mean, many of the architectures we see like a client server architecture, which is this is the client and this is the server. Okay, that means this is the master, this is the slave, like that. And it will basically we can also separate them in this one is, I mean, we can run the client in one server and we can maintain the Docker host in another server. That is how the client server architecture basically works. And also this communication between this will be happened by through the REST API. Okay, and moving back to our presentation, if you see here, we just seen the components of the Docker, like what exactly the components is coming, I mean, is there. And we are just like one more non-technical analogy how it will be working in the backend. um, think of it like a cooking. Okay, where the Docker image is like a recipe and Docker container is a finished dish. Okay, so just imagine this, and by this you can able to clearly understand the things. Okay, basically if you see here the Docker image is a recipe. Okay, with the help of recipe you can prepare multiple dishes, the same dish or modifying a little bit, like that. Okay, likewise the same. Okay, it is like blueprint with the instructions and ingredients, a read only template that doesn't change. It will be a standard. Okay, so Docker file will be written in DSL. DSL is not a language, it is domain specific, which understood to the Docker. Okay, so I too searched about this, like I thought it is written in shell commands or something, but it is not. Not shell, no Python, nothing. It is a domain specific language. Okay, and coming to here, Docker containers. Okay, now we have a Docker image. With the help of that instructions, we are building a container. Okay, it is just like finished dish running instance of an image. Okay, if it is REST, it is Docker image. If it is running, then it will be Docker container. Okay, and you have multiple dishes from one recipe. If you see the example technically, let's say if you have a one Nginx image. Okay, Nginx, and latest was the tag. Okay, this is the image basically. Okay, and we can run the same Nginx in port 80. Okay, that means we can expose to the host node in 80 port, and we can expose the, I mean, run the same image by exporting in another port, that means 8080, and the same image can be done in another port, that is 9000. Okay, likewise 3 containers is created. Okay, so this is the like a small non-technical example, and this is the technical analysis. Okay, and moving to the next, here is the some more understanding you need to do how together works. I just now shown one of the architecture image which is officially okay, like there are components how it was communicating. This is how in the background it works. Okay, like step-by-step flow when you run a Docker container. Let's say your command is this. Okay, you are the here and your command is this particular one, docker run nginx. If you recall that particular image, docker run basically what it does, it will checks it will give a command to a docker daemon which is located in docker host. Let me go back to that quickly. Yeah, docker run basically what it does, it will basically pass the command to the docker daemon, and it will run the image if it is existing. Okay, it will run the image and make it into a container. If it is not there, then it will go and fetch and run. That is how it works. Okay, now let's apply the same thing there, it will works or not. One moment. Yeah, if you see here, uh, client sending, okay, docker client forward, this is the command. Okay, remember this docker run. Okay, so docker client forwards the request to a docker daemon. Okay, now client is forwarding here. Okay, in the first stage just you are running a command, this is the second phase, and docker daemon fetches. Okay, in the third phase what it does, docker daemon downloads the images from the docker hub if needed. If it is not needed, if it is already existing, then it won't go to a docker registry, it will directly run the image. If it is not there, then it will go to the docker registry, which is docker hub, and it will fetch the image, and then it will run the container. In the third step it will daemon creates and starts your container. Okay, so here docker network where containers can communicate with each other through the docker's built-in networking. It's like having private internet just for your containers to talk together. Okay, and there are some more components, I will discuss that also in upcoming video. And this is just like some basic ideology. Okay, to get understanding things from scratch. Okay, and moving to here, um, yeah, this is kind of a real-time analysis, like where the Docker is used in the real world. Let's say if you have your microservices, Netflix have different microservices, Uber, Amazon use Docker to run hundreds of microservices, small microservices, and let's say if we have a cloud deployment, let's say if you wanted to deploy application to a AWS, Google Cloud, or Azure with a consistency, then Docker will come into your picture. And for development also it is very much important. So same environment for all developers, it works on my mission will be resolved. I mean, this problem will be resolved. If you see this problem, it is kind of this is where the evolution of like DevOps came into picture, Docker came into picture especially. Okay, where it will maintains, I mean, the developer only, it will he will only write a Docker image, and he will maintains all the requirements in that container only image itself. Okay, and next moving to the faster scaling, it is also one of the uh, real use case where let's say if, it will basically starts container in very small time, like seconds. Okay, no need to wait for minutes. Okay, and this is also a key benefits for developers, like they can maintain the consistency, same environment anywhere, and there is a isolation also where apps don't interfere with each other, and portability will be maintained. Portability basically means they can run anywhere. Docker will support. Okay, that is basically a portability. And coming to the efficiency is which is more fast and lightweight maintenance. Okay, yeah, this is the some basic idea, I mean understanding on Docker. I think you got certain idea on Docker, and stay tuned for more videos. I will definitely share some more insights in upcoming video. Thank you.